So Newton's first law states that an object at rest will stay at rest, and an object at a constant speed will stay at a constant speed, unless there is external force acting on it.
So you may wonder, how does this apply to hockey? In this scenario, the puck is at rest, which means the forces acting on it are equal. Let's look at the FBD diagram, which explains the motion and the forces acting on an object. In this scenario, the puck is at rest, which means that there are two forces acting on it, F floor and F gravity. F floor is pushing the object upwards, while F gravity is pulling it downwards. They're both balanced and they both have the same force. An object at a constant speed would stay at a constant speed. In this case, I hit the puck, and it was almost at a constant speed. However, F friction slowed it down, and F friction came from the floor. F friction is a force that slows any object down. Let's look at the FBD diagram, which shows the object and a force acting on an object. In this case, the vertical forces are F floor and F gravity. They would stay the same because the puck was not accelerating upwards or accelerating downwards. However, there is F friction, and since there is F friction in the horizontal direction, that means that the object will come nearly to a stop. However, you may wonder, what if there is no F friction? What if there was no force acting on the object and slowing it down? Well, this means that the object will keep going at a constant speed and not stopping forever.
I'll be talking about Newton's second law of motion. Before I start, there's one term you need to understand, which is A, acceleration. Acceleration is change in velocity, which often refers to speeding up or slowing down. Newton's second law investigates the relationship between the net force, the acceleration, and the mass of an object. This law can be summarized into one equation. Net force equals mass times acceleration, where the acceleration of an object is directly proportional to the net force acting on the object and inversely proportional to the mass of an object. Now you may wonder, how does this work? If you're asked to strike two pucks of the same mass, but apply a greater amount of force on the first one, which puck will gain more acceleration? Obviously, it's the first one. But why? Because when the mass of an object is fixed, the acceleration is directly proportional to the force applied. So the more force applied, the more acceleration. That's why, when shooting a puck, players intend to apply more force, so the puck gains more acceleration, which made it harder to block. If you're asked to strike a plastic puck and a rubber puck with the same amount of force applied, which puck will gain more acceleration? It's the plastic puck, because the plastic puck has a smaller mass. But why? Because when force applied is fixed, acceleration is inversely proportional to the mass of the object. So the smaller the mass, the greater the acceleration. That's why hockey sticks has evolved to be made of lighter material, where in 1970s, hockey sticks are made of wood, and in 2017, hockey sticks are made of carbon fiber. And that's all you need to know for Newton's second law.
Newton's third law defines that for every action there is an equal and opposite reaction. The statement means that in every interaction there is a pair of forces acting on two interacting objects. The size of the force of the first object is equal to the size of the force on the second object. We sometimes refer to this law as action-reaction, where the force exerted is the action and the force experienced as a consequence is the reaction. In hockey, when a puck is hit off the wall, the puck exerts a force on the wall, and the wall exerts an equal and opposite force on the puck.